For circle theorem number 3, it says that angles in the same segment are equal. Angles in the same segment are equal. Notice I highlight the keywords. It's the angles that are in the same segment are equal. What is the segment? If you look at my video on part of the circle, you'll know that a segment is bounded by an arc and a chord. So if a chord is drawn in a circle, most cases you have a minor segment and a major segment. Unless it's a diameter that cuts in the center, then both segments will be the same size. But once it's not a diameter and it's just a regular chord, then you'll have a minor segment and a major segment. Now, based on the theorem, all the angles that is in one of the same segment would be equal. So if you see angles in the minor segment, they will all be equal. Angles that are on the circumference. And if you see angles in the major segment that are on the circumference, they will be equal. So if we look at this one, we have the minor segment below the chord and we have the major segment. And you notice that the two angles that are on the circumference, they are equal. So ABD is 40 and ACD is also 40. Now angle B, angle C is 40. How do we apply this now in this question? If you look carefully, we are given the angles PRS, and that's equal to 32. So notice we have P and S. PRS. So you'll just imagine, sorry about that. So you just need to imagine a chord connecting P to S. So you have a major segment, and a minor segment. So these two would be equal. So PQS would be 32. And below this segment, you have 87 here for PTS. So PUS would also be 87 because they're in the same segment. And that's it for the third circle theorem.